Today, we are going to look after homologation in automotive engineering. Definition. Homologation is the official certification process that verifies vehicle system component complies with all applicable regulatory, safety, environmental, and technical requirements before it can be legally sold, registered, or operated in specific market. In simple terms, design, test, document, certify, and then sell. Without homologation, a vehicle cannot legally enter most markets. Why this exists? Government use homologation to ensure vehicle safety, environmental compliance, cybersecurity compliance, EMC compliance, quality and manufacturing consistency, consumer protection, and international trade competition. Examples include passenger cars, commercial vehicles, motorcycles, agricultural vehicles, EVs, and vehicle components. Types of homologation. There are three types. First is whole vehicle type approval. It is approval for complete vehicle. Examples include passenger cars, trucks, buses, and EVs. Tests cover crashworthiness, braking, emissions, lighting, noise, EMC, and ADAS system, among many others. We will see in this in detail. Then component homologation. This is the approval of individual components. Examples include headlamps, connectors, mirrors, seats, batteries, tires. Component receive approval before vehicle integration. Third is system homologation. It is approval of systems such as ABS, ESC, airbags, ADAS, and battery management system. Major regulatory frameworks. This differ according to region to region. For Europe, it's UNES regulations, EU WVTA, E-mark certifications. Examples include UN R10 for EMC, R94 for frontal impact, and R100 for EV battery safety. For US, it's FMVSS, that is Federal Motor Vehicle Safety Standard. Examples include 208 for occupant protection, 214 for side impact, and 305 for electric vehicle safety. For India, it is CMVR, AI standards, and Bharat NCAP. Testing agencies include ARI, ICAT, and GARC. India is increasingly adopting digital and simulation-based homologation approaches. Homologation requirements. Safety requirements. This includes passive safety and active safety. For passive safety, it protects occupant during crashes. Tests include mainly crash test, seatbelt performance, and airbag deployment. Activity safety. Active safety, this prevents accidents. Tests include braking, ESC, ABS, ADS, lane keeping, and AEB. Environmental requirements. Measurements include CO2 emissions, NOx emissions, fuel consumption, energy consumption, noise emissions. Nowadays, the modern vehicles include many electrical and electronic components. So, homologation requirements, there are electrical and electronic requirements which are important for modern vehicles. This include EMC testing, which verifies vehicle does not emit excessive electromagnetic noise and malfunction due to external electromagnetic fields. Typical standards include UNES R10, CISPA 25, ISO 11452. Nowadays, EV occupy a major share of the market for vehicles. So there are EV specific requirements. For electric vehicles, it is battery abuse testing, thermal propagation, isolation resistance, charging safety, and functional safety. Fifth is the cybersecurity requirement. Modern homologation includes vehicle cybersecurity, OTA update validation, software traceability. Relevant regulations are UNES R155, R156. Homologation process includes 8 steps. First one is requirement identification. It determines target countries, applicable regulations, vehicle variants, and required tests. Output is regulatory compliance matrix. Step 2 is design compliance. Engineering team designs vehicle according to legal requirements, SI standards, ISO standards, OEM specifications. Third step is to build a prototype for testing. Examples include mule vehicles, engineering prototypes, and validation vehicles. Step 4 is testing. Tests include safety, crash, braking, occupant protection, environmental tests, emissions, noise, EMC tests, radiated emissions, conductor emissions, immunity, durability tests, road load, fatigue, and environmental exposure. Next step is to prepare homologation dossier, which includes CAD drawings, BOM, test reports, risk analysis, manufacturing information, and compliance declarations. Step 6 is to submit these documents to government authority and certification body as well as technical services for the approval. When approval is granted, certification is issued. Examples: E-Mark, Type Approval Certificate, or COC, Certificate of Conformity. Homologation does not end after launch. Manufacturers must continuously prove production vehicle remains compliant. Activities include factory audits, sample testing, process audits, and traceability reviews. So this is all for today.